Welcome back. I guess to me, you've been here. I've been not there. But hey, it's good to be back. We're going to give it a few minutes just to let people trickle in because it is Saturday morning. But hopefully you all had a nice winter holiday and have been crushing it this semester. I guess I don't even know how, if this class is a full semester, if is it part of a semester because your program is kind of fast. So hopefully classes have been going well. But yeah, we'll give it another minute or so and then we'll get started. Um, yeah. Thank you all for waking up on time. Does anyone have any cool life updates that are shareable um, as a way to kill some time and also catch up?
I adopted a kitten.
What kind?
She's a tuxedo cat. She's 4 months old.
Congrats.
Less than 35 days till I get married.
Nice. That's a big one too. Congrats. Shout out to Debbie hustling. All right. I mean, I'm gonna get started just because I want to respect all of your times. That's a weird plural. Are we canceling class for the wedding? Let's talk about it offline. But along those lines, there's no class next week because of spring break. See that clutch save I did, kind of protecting myself from committing to anything. Um, but yeah, next week there's no class because of your spring break. So just wanted to remind you all of that. This uh, session is recorded along with all other sessions, and that'll be going on my YouTube channel. I'll create a playlist and share that so that it's easy to stay up to date if in case you miss a class or you're late. And then I'll also include that on the course website so it's just easy to find everything in one place. With that being said, I apologize in advance if you hear insane wind sounds or um, my Wi-Fi cuts out occasionally. It's a very windy day in the desert, and sometimes that spells very bad news for my connectivity. And Zoom instantly says your internet connection is unstable. Okay, good to know. But yeah, just yell out or write something in chat in case the connection is bad, and then I can jump on my hotspot. Right. Um, Now, are there any questions before I jump in, besides the canceling class for Fernando? If not, that's cool. Um, oh no, what are the shortcuts? I'm using a Windows wireless Bluetooth keyboard with a Mac, and so remembering how to copy paste is kind of a challenge sometimes. Struggle. So, oh, that's not the full. That's the wrong link. I didn't copy the C. But this is the course website, and it's kind of similar to last semester. I'm gonna have all the lessons, the Google Slides, links to recordings, syllabus, etc. in here. And so hopefully that simplifies things. You still have to submit on Canvas, but in my experience, minimizing dealings in Canvas or whatever it's called now is nice. So that's kind of why I structured it this way. And also it exposes you to different technologies that are used in the workforce, because I've never used Canvas at a job, but I have used all these other tools. Um, with that being said, I'll get off my soapbox and share my screen. So let's share course website. Okay, open chat up again. There it is. Sweet. So before we kind of dive into lesson content, I'm gonna kind of glance over the syllabus a bit. This is linked in the Canvas course website as well, in case you lose this link, but I'll reshare it every week as all our lessons and lecture slides are going to be in here. But this is kind of, I don't want to just read. I guess I'll read this and then I'll kind of give my more unfiltered, not unhinged, but just more unfiltered perspective on how I view this class in relation to your other classes. So spatial information technologies, including remote sensing, are evolving rapidly and are being utilized in a wide variety of areas. This course focuses on Python-centric development and analytical approaches within remote sensing and GIS. The course contributes to the development of competencies that are essential to success in the geospatial and broader technology industry workforce. So I really want to kind of blur the line between really diving into remote sensing techniques and understanding how they're applied in the real world, and giving you kind of exposure to the developer side, the software side of things that you might not otherwise get in other classes in this program. And so this, to me, this course is kind of in ways, a spiritual successor to last semester, in that we're going to be using GitHub. We're going to be writing code. But it's way more focused on how can we use code and the skills we learned last semester to solve interesting problems, interesting spatial problems that are kind of skewed towards the remote sensing domain. And so hopefully that kind of gives some justification on some of the content choices I've made. Well, you can already see some of the stuff we're doing. This might not be a traditional remote sensing course, at least from the maybe OG way things were done. And I think that's okay. Both ways are great. but my journey from being a GIS student into working in tech kind of blurred this line of needing to understand how these things are applied, like in a software, uh, any software, whether that's an ArcGIS software, Erdos Imagine, eCognition, or code that you're writing, and then being able to dig a little deeper and understand kind of what's happening, like how is data stored, or how am I reading files, and how can I automate or optimize things that I'm doing. And so hopefully throughout the semester, we touch both of those, really diving into the domain of remote sensing and solving problems, but then also building up our chops as programmatic problem solvers. So I'm gonna quickly, I mean, I'm not going to go over the course objectives and measurable outcomes here in depth. I do strongly encourage you to read through these at your leisure, but we're going to have mainly a technical focus in this class. I mean, it's applied remote sensing, and we're going to be using code and tools like GitHub. So it's a very technical class, but I hope that that doesn't scare you. You all crushed it last semester, and I expect nothing less this semester. So I really hope you just come in with confidence, but not cockiness, because I'm not gonna just auto A everyone just because vibes are good. You really do need to turn things in, and we'll talk about lay policy and all that jazz at the bottom. But yeah, this is a technical class, but I'm very confident that you all can crush it. And then,
I have a question.
yeah,
So are there is there a section for participation points, or is that not a thing?
that I didn't think that would be a thing, but basically subject to change. Um, I think that that's very important for the learning process. And so that's something that I guess I was hoping there'd be like 25 people in class today. I can't see how many are in because I'm screen sharing right now, but it doesn't seem like it. And so I'm going to reevaluate that. I might even do, I mean, later on, you'll see there's methods of like how you can get points and like demonstrate that you're here. And so there might be some extra credit opportunities that are in class only, that if you're not here, it's just sorry. So that might be a way to get at that participation points. Um, yeah, that's a good question. And I'll follow up as I kind of ruminate on that over spring break. But no extra credit this week, but that's something that I will discuss in a bit. And throughout the semester, there will be opportunities. And this kind of is a data point for me that they should probably be maybe in class ones to really reward people that show up and are putting in the work. But yeah, good question. Does that answer it?
Yeah, thank you. I was just wondering, since I did see the lack of people here too.
Yeah. And I'm not sure if that's something, maybe I didn't notify them early enough. My bad if that's the case, but next week or the week after spring break, we'll have more data. But yeah, thanks for calling that out. So analytical. So not just learning really technical things for the sake of being technical. Like, I'm not trying to make you engineers necessarily. I mean, if you want to become an engineer, that's awesome. Let's talk. But not everyone wants that. And that's amazing, because we don't just need everyone to be an engineer, but we do need people that are able to kind of put on a more analytical lens. In my experience, engineers and a more technical approach can kind of lose sight of what's the problem being solved. And so I think that at the end of the day, that's kind of how I view this analytical part of the course. I'm going to really try to emphasize why, because like technology is cool. Yeah, like I think on some level we all think GIS is nice and like dandy and awesome, and just like interesting, but that's not enough. Like, you actually have to be solving a problem and like adding value to your company or your society. You know what I mean? And so hopefully throughout this semester, we also discuss how GIS practitioners and scientists and researchers are answering or posing interesting questions, hopefully answering them using these technologies. Business, that's another really important one. We're all living in under global capitalism. Like it's just the reality we exist in. And so understanding, I mean, it's important, it's like professional ethics and rules of conduct, but also how to navigate your skill set and marketing yourself as a potential employee or collaborator or founder, depending on where you're at in your professional career. And so I think that understanding that what you're learning and understanding about remote sensing, try to put on, maybe business is the wrong word, but like a professional development kind of lens and how it can enhance your portfolio or your understanding of problem solving as a professional. And so I think that that's underemphasized, at least in my experience when I was in school, how to kind of hype up a little more your experience to the lens of getting hired. And then finally, interpersonal throughout the semester or whatever, this course, I guess. I do want to give you some opportunities to demonstrate understanding of like maybe a discussion or some video that we all watch, and sharing your opinion and maybe informed by fact, or not maybe, but definitely informed by some sort of fact. And this isn't some kind of in-depth research report so much as I want to mix it up and remind you all that engineers and people working in tech also have to kind of blur the line and not just write code all day, every day. There's a lot of research and kind of team discussions involved. And so I do want to touch on that a bit this semester, not overboard, but there will be at least one kind of group sort of discussion with like a prompt to write on. Okay, methods of instruction. The main one is lectures, which is what you're here today. So thank you for showing up. Very appreciated. If you're here and you're in class right now, I'm going to be writing a word in chat, code word. I'm not going to say it on the recording, so it doesn't give it away to people who weren't here. But if you email me this code word, I'll give you 5 extra points. So yeah, thank you for showing up. And this can be the first welcome back gift, but yeah, hopefully this incentivizes showing up. For those of you who didn't show up, I don't think you'll be able to see the chat. So sorry, but show up. Okay. Besides lectures, which will kind of, like last semester, I'm not going to go crazy and have like 2 hours of lecture. I don't think that's super productive for this kind of class. So I'm going to keep them brief and really kind of give an overview of what we're going to cover through the applied lab exercise. But it's also an opportunity to sit back and reflect together. And so this is probably where I'll throw in some of the group discussion type things. Not sure if we'll go with breakout rooms. I've never done that, but we'll look into it. But yeah, that's kind of the general structure for lectures. When I find some interesting content that I think is really valuable, I will not hesitate to share it with you all. And so in my experience, YouTube is a great source for interesting podcasts, conference talk recordings, and other just interesting content. And so as I find things, I'll definitely share them with you all and strongly encourage you to watch them, even if it's on 1.5 speed. I'll make sure not to send anything that's crazy long, but it is a nice supplement or complement to the main lecture content and lab exercises. And then, like I've been alluding to, the group discussions, which will kind of be sprinkled in. Methods of assessment, mainly computer lab exercises. So similar to last semester, it's going to be kind of an assignment that leverages GitHub, some kind of programming on your local computer, and then submitting that via Canvas, like a link, and then I'll give you feedback. And it's really kind of building off of what we go through in lecture, and I'll walk through the labs with you. And so there's really a benefit to coming to class because we can kind of go through any questions in real time. But if you have any questions after class, don't hesitate to send me a message or ask your classmates. And really just encourage you to at least try. You will be surprised how far you can get with points if you at least try. So I wouldn't suggest just submitting a blank or not submitting anything. Most of these labs, it's kind of a matter of following through and making sure you're copying everything correctly, or not even copy pasting, but typing it in correctly. And so I have faith that you all can get full credit on pretty much everything, unless you're late. And then we have extra credit opportunities. There'll be no less than 3 throughout the semester. You already saw the first one, just kind of more of an attendance, like thank you, but there will be extra credit opportunities and more info to come on that. Grading policy is pretty standard in terms of breakdown of grades. Greater than or equal to 90, you get an A. Greater than or equal to 80, but less than 90, get a B, etc. I hope everyone gets greater than 90. So let's try to lean into that from day one. I'm going to be a little more strict this semester on late policy, just because I was pretty lenient for the most part. And so still being pretty lenient, but really do encourage you to turn things in on time. I know life comes up, and that's just, I totally understand that. And so if life does come up, let me know. Don't just go radio silent. I'm pretty accommodating if you reach out. So just let me know if something comes up where you're just not able to turn things in. Same thing goes with if you need any kind of accessibility accommodations, please don't hesitate to reach out. I think the Accessibility Center will probably send me some automated email, but if you feel like having a message to me for more just kind of the specifics or how it works for you in terms of accommodations, let me know. I'm super laid back and want to make this class work for everyone. Along those lines, I think that the YouTube recording will allow captions, so I hope that helps as well. Yeah. And then helpful links as they come up, I'll add more, but right now it's really just my YouTube channel. I'll update this, or I'll update the channel with the playlist once this recording goes live. And likewise, I'll update this video recording section with that playlist. Right now it's blank. So that's really the syllabus. Before we go on, does anyone have questions about the syllabus? I guess before the question, I will kind of finalize a little more the kind of attendance type points, and then give more clarity on extra credit throughout the semester. But are there any other questions?
Hey, Alex, I have a quick question. I know you said to email you, but I can never find your email. And then I know that when you try and email yourself, like to email you just on like our Outlook, it says that like this doesn't, like
Yeah,
it's
yeah,
unavailable. So should we do it on your Gmail? Should we do
yeah.
it on Discord? What works?
Uh, I don't know how to turn that thing off in the Outlook, so maybe just Gmail, and I'll post that in the syllabus.
Okay, great. Thank
Let
you.
me just update that after. You know what? I'll just do it right now because I will forget.
Okay, thank you.
Yeah. Seeing how the sausage is made. So I use a platform called Gitbook, and it's a way to kind of integrate with GitHub, use Markdown to create websites, mainly for technical content, but it's super convenient. I see someone has their hand raised. Matthew.
Hey, Alex, welcome back.
Thanks. What's going on?
Are we gonna touch into anything dealing with like the integrated ArcGIS Pro like Python window? Are we gonna touch into that?
I was not planning on it, but we can definitely, if that's something that would be really interesting to you, we can definitely look into it.
Yeah, I found it really cool. I was able to like use it for work. I thought I don't know. I did it for like an exporting layout issue. Where essentially like when I was running the export layout tool, like it was taking us like 3 minutes to like export a layout because I think it was an old project. And like essentially like into like the Python window just like bypassed that wait time, and I don't know,
That's right.
it took a lot of like chat GPT to like find all the errors and whittle it down. But I don't know, I think like it's valuable. I don't know if that's something that we could go into, or I kind of have questions on it on my own just to like to see if there's anything else I could like do with it. So down the line, I might send you that code that I wrote out and see where it might need tweaking or whatnot.
Yeah. Okay, cool. No, and
Okay.
to me, that almost sounds more like an idea for potential extra credit thing in the semester where maybe if you're diving into something that isn't on the course menu, but is like very related, you can present to the class. And then part of it can be open-ended where you have questions and like future research. Because I think that's a lot of kind of what work is. It's like you don't have all the answers necessarily all the time. And so I don't know if that's fully satisfying to you, but to me that could be a cool way that it opens it up to other students as well that are also going off menu in their endeavors.
Yeah, sounds good. I'll look into it for sure.
Cool.
Thanks.
But yeah, I'm curious to learn too, because I personally, I don't use it. So you're more of an expert than I am. So I would like to default to you and learn from you. So yeah, that's also why I think I bring up the extra credit thing, just because then you could be the instructor for a section. Yeah. All right, cool. So I've updated the syllabus with my email. Thanks for calling that out. See, boom. So reach out to me. I'll get back to you. And if you send it via Canvas, that should also reach me because in Canvas it just like emails it there. So I will check probably tomorrow. But yeah, don't worry about grades. I'm not going to really rush on grading because it's spring break next week. So we did syllabus. Were there any more questions before I jump into code of conduct? Sweet. Don't hesitate to unmute or post in chat. I'm keeping chat open so that I can keep on top of it. Also, shout out to ChatGPT for helping me generate this code of conduct. The machines and humans will coexist peacefully. So we are a virtual class. We are. I know that we generally are. There's some like good vibes in the cohort, but I think it's still important to have some kind of common understanding of what is cool and what is not, and what is like disrespectful or what is unacceptable. And so I'm not really worried about this at all in this class. Like everyone's kind of a sweetheart. So it's really just out of like a undue caution or just abundance of caution. But I really want to, I will enforce that we have respect and kindness toward each other. I'm not going to read through all of the machine generated content, but may you behold the glory of AI. I do really want there to be a willingness to learn and help others. I think that learning together is really important. Sometimes you're not the expert in a thing and someone else is, and that's just a fact of life. And I think that being able to very easily jump from kind of teacher mode to student mode is a necessity to do well in many, many jobs, because you're collaborating with people who are oftentimes extreme experts in their field. And then you're oftentimes the extreme expert in your field. And you have to have a discussion about things where there's overlapping work. And so I think that you need to learn to kind of be respectful and kind across experience, and being willing to help others maybe get to your level and vice versa. Also, I will not tolerate kind of plagiarism. I mean, that's not really an issue in this class. It's all open source code. You're not kind of monetizing it and saying that it's your unique academic contribution, but this is more geared at the short kind of blurb type assignments I might give you for extra credit, like discussion type, write a quick paragraph thing. So do not plagiarize. In terms of ChatGPT, I'm pretty flexible with that. I think that it's more, don't just put in your prompt and take the first answer. That's like, come on, don't be that lazy. I think that there's value in working with the machine or the AI to kind of iterate on an idea, but don't just copy paste their answer. But I'd be lying if I said that I don't use ChatGPT myself at work. And so I think it's a valuable tool. So use it with caution. And if you have questions about that, don't hesitate to ask, and like bring it up in class or via email, because these are kind of questions that are happening not just in classes, but in businesses and like industry. Like, how do we deal with AI and code? So I see Matthew has a question.
Yeah, I don't think I'm outing myself because this is a safe space for ChatGPT
Yeah.
in this class. So something that I found very valuable in this program as a whole is not write me a paragraph expanding on this idea or write me a paragraph. It's write me an outline, and it just gives you little words, and then it's really opens up like me to like expand on those ideas with my own words.
Exactly. Yeah. That's like the wise usage. Yeah. I mean, if you think about it, a lot of software does that for us already. Like, it's not using quote unquote artificial intelligence, but like a preset. We're just asking the computer to generate us a preset for like a specific type of content. You know what I mean? So if you come from it from that perspective, I think it's much more safe and you're not just regurgitating nonsense. But yeah, thank you for that feedback, Matthew, or that insight into your own usage. And yeah, I'm not like going to report anyone. I think that's obscene. But yeah, I'd be curious also if someone wants to go into using ChatGPT as a helper, but not relying on it as just your teacher, and how like the pros and cons of that. That could be a cool like mini presentation and your experiences with it. Because I know I know so many engineers that use it not for giving them the answer, but just kind of getting them in the right direction or thinking about the right thing. And I think that that's a super powerful tool. Yeah. All right. Timeliness. Please do submit assignments on time and come to class. Let me know if you can't make it, but respect those who made it today. And no hate on those that didn't, but try to make it next time. No grudges held here. Just want you to show up and be part of the learning community with us, because then it's more fun. Communication, just be professional and respectful with each other. Don't use any hate speech or words that could be misinterpreted when possible. I mean, that's kind of a very generic statement, but just, yeah, be kind and respectful to others. In terms of technology, let me know if you're having any tech issues, like ASAP, and I'll help you resolve them. I tried to do everything in the cloud so that it won't be an issue, but let me know if you run into problems. I think that these instructions should work across all of your computers, regardless of whatever local, like nothing is going to be done on your local Python. There should be no issues with accessing a specific version. So it should just be streamlined in that respect. But let me know if you do run into problems. Confidentiality. This is kind of like, if this is a safe space. And so like, yeah, like you're talking about your usage of ChatGPT, I'm not going to go mention it to others. And there might be other conversations about that. I mean, keeping it respectful and in the context of professional and what we're learning, but just reinforcing that this is a safe space and I'm not here to report or narc on anyone. We're just trying to learn together, and sometimes that can get emotional too. And then accessibility. Please do let me know ASAP if you need accommodations, even if it's not officially through the school. Within reason, I'll try my best to make it work for everyone, because I think that's just fair. And then if you're a jerk, I'll probably just bring it to Wexler. You know what I mean? So just don't be a jerk. But I'm not really worried about that. But yeah, and I think that's really it for the code of conduct. If you have any questions, let me know. But it's kind of just a lot of standard stuff, I think. And then the semester schedule. So before we jump into today's content, I just wanted to go over kind of what to expect this semester today. And so yeah, classes meet Saturdays 9 to 1:30. I don't expect us to stay that late. I'm guessing we'll be done by kind of 12:30. I know some people like to work independently off camera after lecture. That's totally fine. I know some people like to stay to the very end, hanging out, even if they don't have questions, just kind of working together but separately. That's totally fine too. So just do whatever works for you. Just make sure you show up to the beginning and say what's up, and then make sure you turn things in on time. And I think it should be the same Zoom link every week. So it seems like from the CSULB Zoom portal, but if it isn't, I'll send a new email next week. So this week is the last week of March, which is kind of crazy to think about. This year is already going by super fast, but we're going to do kind of a deep dive into, not a deep dive, but yeah, sort of a deep dive into using Python for more kind of numeric computations, and using two really common libraries that are used in the data science, data engineering world, not just in geospatial, but in just tech generally, and that's Numpy and Pandas. So we're gonna dive into that today, and that lab is due April 13th before 9 a.m. So before our next class session, just make sure it's turned in. Anything after that will be considered late. So just wanted to make that very known. So you have nothing due next week, but you do have the assignment due in 2 weeks. So no class on the April 6th. April 13th, we're going to be doing our first foray into vector spatial data in the Python realm. And so you'll have a week to do that assignment. Following week, we're going to pivot from vector to raster spatial data, because when you're doing analyses, it's often using a larger raster data and then kind of zooming into specific vectorized locations. And so having an ability to leverage both of those data types with Python is going to serve you very well. So we'll cover raster spatial data on April 20th, and that's due April 27th before 9 a.m. On the 27th, we're going to pivot into LiDAR data, which is pretty exciting. It's a cool kind of very data rich, that's a bad way to describe it, a data rich data type. It's big data in the sense that you're having multi-dimensional information. And so the ways that you analyze LiDAR data are very different than raster or vector data. So it'll be cool to kind of see those different techniques. Again, you'll have a week for that lab assignment. On May 4th, we're going to jump into multispectral data, which is kind of using raster data in multiple or multi-layer raster data, and how to analyze, do basic operations using Python. Again, you'll have a week. And then we'll jump into spectral indices using Python on the 11th. You see a pattern, you have a week for that. And then on May 18th, that's our final class. And we have our final exam, and that's due on May 19th before midnight. I don't expect it to take you all that time. You all did stellar on last semester's final, so you can kind of take that as a general expectation of difficulty or length to complete. So does anyone have any questions about the schedule? Talissa, what's up?
Is the final exam similar in format as the last semesters?
Yeah, it should be.
Okay. Thank you.
Similar kind of format and difficulty and length. Yeah. Cool. And then in Canvas, you see the breakdown of the labs, but with the exception of the final lab or final exam, all labs are 10 points, and then the final is worth 20. And then the extra credit will kind of vary throughout the semester. Like the one from today, I said is 5. So can I add that right now? I'll do that. Actually, let me do that right now because I will forget. Sorry, but it's for your points. For now, I'm not going to add it as required because then it'll kind of take points away from people, but I will add it to your final grade at the end of the semester. Day 1 attendance 5. Mission type. Or no, there's a online, and you just need to put in the code word. Actually, no, because you're emailing me. No, but this way is actually kind of easier. I'm sorry to add more work to you all, but for those that see the code word, submit it in this assignment. So, are there any questions before we jump into the slides for today? Cool. So, using Numpy and Pandas, day 1. Kind of been teasing this already throughout the last 45 minutes, but the focus of today is kind of familiarizing ourselves with these two really like industry standard libraries and not doing anything too crazy, but just getting our sea legs again in case you haven't coded since last semester. In case you have, this might be like boring or a little slow. And if that's the case, sorry. But I'm viewing today as kind of like a let's get recentered. Let's get back to where we were. And that's also why you have a little longer. I didn't want to force you to submit something on rest week too, or not rest week, spring break. So let's dive right in. Today in the labs, we can kind of group what the learnings that I'm hoping that you're gonna internalize into these 4 categories. Doing some, or just dealing with numeric data. So very vague, but just the way Python handles and operations that it can do on like words and strings and characters is very different than those that it can do on numbers. And so getting some familiarity with the number specific operations is really kind of the goal. And then once we're kind of familiar with those numbers, it's doing some basic calculations. So like addition, multiplication, subtraction, things that we've kind of done in the past, maybe in elementary school, but also things that we do as GIS practitioners, having to lay the foundations to delete rasters from each other, creating a difference image of change after a burn. And so these kind of simple subtraction operations are actually used in more sophisticated use cases. Then we're going to get some experience handling text files that contain numeric data. So you can think about that as like CSV files and similar outputs or similar file endings. And so understanding kind of the basic way Python can manipulate that data, do calculations with it, and then maybe save it somewhere, and then kind of stepping it up one notch to use, or kicking it up a notch to use Emerald speak, doing spreadsheet type operations. So this is stuff like those things you do in Google Sheets or Microsoft Excel. You can also do that in Python via Pandas. And so this is really kind of a non-spatial week, but it's really foundational to all following weeks because we're going to be using these libraries either in conjunction with or kind of behind the scenes to do our GIS stuff. And so this might not seem super, super relevant now, but throughout the semester, I think you'll learn or you'll appreciate the week 1 kind of lessons. So it's kind of just diving a little more into what I was blabbing about in the overview page just now, but for the dealing with numeric data, we're gonna kind of check out 2 paths. The first one is the standard kind of default Python types using list. I use types in quotes because in other programming languages, there's a much stronger understanding or idea of type. Python is kind of, it dabbles, and so that's why I'm using it in quotes. And then after we get experience using lists, we're gonna change our focus onto Numpy arrays, which will be really cool and help us start dealing with data that's not just like a X by Y, like square or rectangle, but multidimensional grids. And that's kind of one step closer to raster, like multispectral raster data. That's like an image that has 7 layers. And so Numpy arrays are kind of the foundation of a lot of computing libraries in the Python ecosystem. So getting some experience here will be very good. And then we're gonna do some calculations with those numeric data, again, using default Python and NumPy, and then getting some exposure to 2 new libraries that I don't think you've seen yet, unless you've done some extracurricular coding. But SciPy, which is kind of the more scientific algorithm focus library, kind of the older brother to NumPy. And then Pandas is really where you can streamline and do a lot of spreadsheet type things. And so you can also do basic calculations, but Pandas is a super powerful library. Again, we're gonna learn how to handle basic text files like TXT and CSV. We're gonna dive into spatial data files starting I guess in 2 weeks once we get back from spring break. But oftentimes when you're doing a spatial data analysis, or not just a spatial data analysis, but an analysis that involves spatial data, there's also non-spatial data. So maybe there's sensor data that's just a CSV file of sensor measurements, a rainfall gauge. And so you will have mixed data sources. And so you need to understand how to handle not just spatial data, but non-spatial data with Python, and being able to perhaps merge and join them to do more interesting analyses and gain insights that are valuable. Finally, spreadsheet type operations, really leaning into Pandas, which is a super amazing library that lets you read CSV data, Excel data, and a variety of other data types and kind of turn it into a spreadsheet. And then you can do crazy Excel type things with built-in functions that let you do kind of statistics and man, I sound like a nerd. But yeah, it's actually a very powerful library that's useful. I used it when I was a student, but also when I worked at Esri and before, to just kind of clean data to use it somewhere else. So kind of part of a data extraction pipeline for ETL stuff so that people can get the information they need. So Pandas is really great for that purpose when you need to automate data kind of cleansing. And GeoPandas is the GIS, I guess, cousin to Pandas that lets you do many of those same spreadsheet type operations, but on vector data, which is super cool. Another one that we're going to jump into later this semester is Raster.io, which is, it's a little different user experience, but it lets you manipulate raster data using Python. And so we'll get some experience using a variety of different libraries throughout the semester. With that being said, that's all I really have for slides. Are there any questions before we jump into the code? Okay. So let me I'm already getting parched. I'm not used to talking. Making it sound like I'm mute. No, I don't talk this much continuously ever, really. So we're going to use Numpy and Pandas, and we're going to use GitHub to demonstrate to the world, not just to me, but to the world, that we're learning how to use Python. And so for me, part of this class, I'm trying to help boost your quote unquote developer street cred, or just your technology street cred, that you're doing things, you're learning, and you're publishing that so the universe can see it. I mean, no one's going to necessarily say, wow, you're the best thing since sliced bread because they saw that you uploaded a tutorial notebook, but it's demonstrating incremental growth, that you're learning a new skill and you're continuing at it and you're getting better. And so to me, I'm viewing this much more as like you're laying the breadcrumbs for when you're slamming those resumes into LinkedIn and whatever. And the hiring manager can also check your GitHub and be like, oh, wow, they're not just full of it on their resume. They do know GitHub. They do know Python. Maybe they're not a computer science student, but not every role needs that. Like many roles do not need that. Like that would be bad. And so I think that getting some more comfort, not shilling is the wrong word, but like hyping yourself up a bit and using technology to demonstrate that you're doing things is valuable. So that's why I want to have you all submit things in public on GitHub. Before we jump into actually doing things, I'm kind of just going to walk through at a high level what we're doing today in the lab. But yeah, we're going to create a GitHub repo using a template repo. And then we're going to open that repo in GitHub Codespaces. So this is stuff we did last semester. So it might be a little foggy, but I know you have a little bit of a distant memory of doing this at least once. And then in that code space, we're going to create independent Jupyter notebooks for each of these lessons from University of Colorado Boulder's kind of Earth Data Science initiative. And so these are really great for learning NumPy and Pandas. And so each of these lessons, we're going to create a Jupyter notebook, and along the way, committing those changes to the repo. And then once you're done with all the labs or all the sub-assignments, you'll just submit that URL on Canvas. If you're afraid of forgetting to turn it in on time, don't hesitate to just create the repo and submit it on Canvas, but then make sure that you do finish all the labs. If you run into issues using GitHub Codespaces, I've provided an alternative development environment. It's called Google Collaboratory. And this is, if you have a Google account, you have access to kind of a Python development environment inside of Drive. And so that's kind of an alternative to GitHub Codespaces. If you take that route, you'll need to kind of download your notebook using like a file download kind of menu bar and then upload it to GitHub manually. So if you do that route, let me know if you have any issues, but it should be fairly straightforward. Yeah. With that being said, before we jump in, are there any questions or concerns? All right, I'm gonna stop sharing this screen and share another window. Okay. So this is my GitHub. Here we can create a new repo. So I go to my repositories pane. I'll click new. I already noticed a typo here. Oops, I'll fix that later. So we want to use a template. We got to find how to create a repo from a template. So it's a little easier if I had the link to the repo. Didn't actually provide it. Let me do that in the instructions so that it's not super annoying for you all. Come on, forgetting the Windows keyboard. So this is the one that we're going to be using. Let me quickly update the instructions before I forget. Cool. Perfect. A little rusty. It's been a minute. All right. So in a second, this should merge, and then we should have updated. Take a second before it does. There it is. Okay. GIS 606 Lab 1. So if you refresh your page on the course website, it should have the updated link. And if you hover over GitHub Codespaces Jupyter, that now links out to the repo you need to use. So let's use this as a template. I'm going to create a new repo. I'm going to call it GISC 606 Lab 1. I'm going to call mine live because I'm doing it live, but like for the demo, then actually I'll just call it demo. But for you, make sure to title it just lab 1, and then set the visibility to public, and then create the repository. Might take a few seconds. Okay, cool. For everyone who's following along live, are you here or past this already? Just give me a thumbs up or something in chat, just so I know that I'm not leaving anyone behind.
Hey Alex, I think I missed the template issue.
Okay, if you go to the instructions on our course website and you hover over where it says GitHub Codespaces Jupyter, that's now a link. You might just have to refresh your page, but if you open that link, you can then use that as a template repo. And then I've linked how to do that, but there should just be a button that says use this as a template.
Okay.
And then click the create a repo option. So now let's open our repository in the GitHub code space. So there's this kind of green icon, and then by default, it has the local option, but let's toggle to the code spaces pane, and let's create a code space on main. That's really just the main branch. If you had multiple branches, you could specify a different one, but let's just use main. Might take a second for the code space to set up, but
Hey, Alex.
hey, what's up?
Sorry to interrupt. I'm not sure if
No
it's
worries.
just me, but I'm having on the website, I don't know if it's just me, but I only see a about section and code of conduct. I don't see links to anything else.
Are you on GISC 606, alexbackonishkus.com?
Oh, I think I'm on your GitHub. My
Okay,
bad.
for sure. Yeah, no worries. Yeah, that's all good. But yeah, just use the link, because I think the GitHub might have some old stuff that's not, it's a little stale. Whereas this the site that is on my like domain name is updated.
I found the right one. My bad.
Okay, cool. No worries. No, thanks for reaching out. So as you can see, I didn't actually run anything, but GitHub is creating a development environment here for me, and it's using a Python tool called pip to install everything that's in this requirements file. And so this is a way for you to install libraries that you might want to do code with. And so you can see by default, we already have Numpy and Pandas. If we were doing other things, we might have to change this file and add new things. But for today, this Jupyter Notebook already has everything we need. So that's kind of nice. And this is a way you can see that if you're maybe sharing an analysis with someone, you're able to package all of this together so they can reproduce what you did on their computer. So we have this Python development environment. If we kind of look here, we have this folder called notebooks. I'm gonna go into this folder notebooks. Actually, no, I'm just gonna do it in the main here. So new file. I'm gonna call it intro to numpy.ipynb. And you can see the code space kind of auto-magically understands that I want it to create a Jupyter notebook for me using Python. And so this is all kind of borrowing from the Microsoft Visual Studio Code experience, because GitHub is owned by Microsoft. But if you've ever opened a program called VS Code, it looks pretty dang similar to this, but it's kind of just a VS Code in the cloud connected to your GitHub. So it's super convenient. But now that we have this development environment ready to go, let's open the instructions for Intro to NumPy Arrays. So this is what it looks like I'm gonna have this on my other screen just so that I'm not having to constantly toggle tabs. But I am sorry if you only have one screen. You can also squish them next to each other and just make them tiny. But yeah, I'm only sharing the one so that you don't have a very wide view. But let's go and kind of look through this. This is part of a longer kind of course on reproducible science, some of which is we've covered in the previous semester, and then some of which we didn't. And so this is kind of the stuff that we didn't really mention too much last semester. But really using scientific data or working with scientific data using Numpy arrays. And so we're going to dive into Numpy arrays, how to import data from text files, run calculations, and create summaries, and then kind of selecting specific data from those arrays. The instructions that they've listed about what you need don't really apply to us because we're working in GitHub code spaces, but as we kind of work through different lessons in the semester, we might have to adjust our code spaces environment, and I'll update our instructions accordingly with the steps to get set up. So before we jump in, I guess I will share the screen because we're not coding quite yet. But NumPy arrays they're commonly used across different sciences, not just GIS, but like physics, biology, et cetera, et cetera. That was only two, but that's a lot of subdomains in those categories. But NumPy is really common in scientific computing. It's storing data kind of as a grid or a matrix. And for those of us that have some exposure to remote sensing data, that's exactly what a raster image is. It's just a grid or a matrix. And so you can see how NumPy might be useful for our endeavors with Python remote sensing. And then in Python, we're kind of diving into slightly more computer science-y terms now about data structures. But it's really just a way to store information kind of in some sort of useful bucket. And so these let us kind of organize and manipulate data that are useful for us and kind of select information from it, create more complex programs that rely on data computations. So something like Microsoft Excel is a bigger software that's using a lot of smaller software components to do things like math. And so this is kind of one of those foundational chunks of software. So Python lists are something that we previously kind of dabbled with a bit last semester. You might see it with the, I think we did. It's where there's like a bracketed, square bracketed kind of entry of numbers here on this page. This one is prefixed with numpy.array. So that's how you know it's not just a list. But if we were just in pure Python land, this is a list. And so just select Python 3, 10, 13. Forgot to do that earlier. But now you can see we have this list variable called this is a list. You can select specific entries from this list using integer-based indexing. But with NumPy, you can do a bit more. So the key differences between lists and NumPy arrays, all elements in a NumPy array must be the same data type. And so that might seem like kind of an unwanted restriction at first, but the flexibility of Python lists that you can kind of just throw whatever in there, it's great for kind of smaller, less structured problems. But as soon as you're dealing with scientific data, if you're having string data, numeric data in the same kind of grouping, that really messes up any statistical calculations because you're having to handle that. And so being able to standardize to a single like integer or decimal data type in an array is super valuable. And because of this, arrays let you do arithmetic and other mathematical things on each element, which is something lists can't really do. And then NumPy arrays are also a bit more, they're useful in the in certain performance contexts. NumPy arrays are just faster than lists. And then it lets you store data in multiple dimensions, whereas lists are kind of, you can kind of do that, but it gets messy really fast and just not really usable from a developer perspective. It's just NumPy arrays are much better suited for those sorts of kind of multi-dimensional data storage problems. And so throughout today, we'll kind of get some experience with that. So they can be 1, 2, or multi-dimensional. A one-dimensional array basically resembles a list. And then it gets a little crazier as you add more dimensions. We're mainly going to be working with 1- and 2-dimensional arrays today, but in the semester, we're going to be dealing with 3 through, I don't know, like 7-dimensional arrays for the multispectral data. So it can get very very fast. So now that we're kind of past the initial chatting in this lesson, let's toggle back to code view. And I'm going to import NumPy. I'm also going to use import aliasing because it's annoying to have to write NumPy anytime I want to use a NumPy function. And so developers are notoriously lazy. And so you can import NumPy as MP, and then you don't have to write NumPy every time. You can just write NP, and the computer will just know. So let's create a variable called average monthly precip. And it's just the average precipitation for January through March in Boulder, Colorado of this fictitious year. So average monthly precip. And I strongly encourage you to type and not just copy paste, because building that muscle memory will really suit you in the long term in terms of like remembering how to structure things. I see you have a question, Matthew. What's up?
Sorry, I was muted. I think I missed it or I caught it, but it was like you changed like the format to like a Python. Like the code space is just different. Yours looks different, like yours is in blocks.
Okay, yeah. So when you run, like when I ran this code block, it gave me an option like select kernel or something. Do you see that?
Let me try running that again.
Yeah.
1 second. It was like this is a list.
Yeah, just run that first block. Because it's something with the kernel, and then it should be like select kernel or select new kernel or like Python, like existing Python. Do you see anything of that?
I have like this is a list equals and then that list that in the brackets.
Yeah.
And I can run it. There's like a play button.
Yeah. Just hit the play button. What happens?
It shows up in my terminal.
Interesting. It might be worth doing the old delete the file and recreate it again trick.
Okay, I'll mess around with it. It's not.
Yeah,
it's
I would
not,
try that. Yeah, and if you keep running into issues, let me know, and we'll
I will.
debug it.
Thanks.
So let's invoke the NumPy array method, and inside it, we're going to specify the values that we want to put in our array. So in a real world use case, this would all be coming from like a sensor or something. So we wouldn't actually be manually typing it in, but it's a toy example. So we're kind of learning, but we have this variable. Let's also print out the variable. And the nice thing about Python is that it has a sense of autocomplete. So you can see I just put in AV and it already knows that's the one variable that I've created that could possibly fit this pattern. So you can just press tab and it auto-completes for you, which is super nice. And then another trick, you might notice that I'm never really clicking the play button. That's because I'm doing Shift Enter, and that runs the code cell that is active. Magic. So you can see that the output is a one-dimensional NumPy array, and it kind of just looks like a list. Like if I printed this is a list, it looks pretty dang similar. So what's the deal? Let's try it with 2 dimensions now. Pardon the excessive typing, but it's part of learning. So precip typing is a challenge at times. 2002 to 2013. And this is the monthly precipitation for January through March in 2002 and 2013. So the first kind of array is 2002. The second array is 2013. So np dot array, and you'll see here they're kind of doing some multi-line trickery. So let's follow them. So 1.07, 0.4, 1.50, and then we'll do a new line. Even though I have a numpad, I never learned how to use it. It's too much for my little brain. Print, precip. Okay, so we're starting to get somewhere a little different now. But it kind of looks similar to a list, but you can notice that there's 2 sets of brackets now, and that's an easy way to tell if it's a NumPy array or if the NumPy array is 2-dimensional or more. When we have another one with 3 dimensions, it'll be yet another set of brackets. So that's really it for this lesson 1. Let's commit our changes to our repo. So we got I forgot which one of these it is. Source control. So it's the one that's kind of like a branching thing. So the source control tool we're using is Git. And so Git detected that we have a new file with changes. Let's make sure we save that file. Let's commit and create a pull request. No, so let's commit and see what happens here. There are no stage changes to commit. Would you like to stage all your changes and commit them directly? Yes. Please enter a commit message. Finish lesson 1. And then accept commit message up here. And then let's sync the changes. It's okay, don't show again. And then if we go back to our repository and refresh, you should see we have a new file, and it's a GitHub, or it's a Jupyter notebook that we created in GitHub Codespaces. So that's going to be the flow for the remainder of the lessons today. And so hopefully the number isn't too daunting, because you can see that they're actually not super involved. It's really just, we're getting our sea legs back. So I'm going to head back to this code space. I'm going to close this file, and then I'm going to toggle back from the source control pane to the Explorer pane. And so now I'm going to return back to our course website. And we'll see that the next lesson is import text files into Numpy arrays. So before I go full code mode, let's read through this and see what they have to say. So scientific data can come in a variety of file formats and types. We just got some experience with Numpy arrays, but we created those kind of ourselves manually. But a machine might output data in a TXT or CSV format, and so like some kind of atmospheric sensor. And so we want our code to be able to read that in and automatically just handle that transformation for us, so we don't have to worry about it. And so an example of plain text files are this NOAA average monthly precipitation data set. You can just see that each new line has a separate measurement value. And so you might see this from some sort of sensor that's deployed in a region, and you might be an analyst that is given a couple dozen of these that are from different locations, and you have to do some analysis on that data. They're useful for collecting very large data sets that are all the same type, such as like a mesh grid of rainfall detector sensors. Another plain text file type that you will encounter is the comma separated file. There's variants like tab delimited, tab separated file, or semicolon delimited, but it's really just there's a use of a symbol or delimiter to specify a new entry, and then a new line is kind of a new row of data. And so in this example, we have monthly precipitation for Boulder for the years 2002 and 2013. So each row is a new year. So each date is a separate line, and each month of data is separated by columns. So this is January 2002, and this is January of 2013. So yeah, like we learned that you can manually create these arrays, but that's not super practical. So let's do some code. So I'm going to move this over so that I have it easily visible. Let's create a new file. You could also use command line kind of functions like touch and then creating a new file, but I'm just using the Explorer because it's nice and it's just easy. So we have to call this file import text files.ipyonb. Oops, disappeared. Cool. So let's get started. I think this is where you ran into the issue previously, where it's like there was no kernel selected. So you can say select kernel and then pick Python 3.10.13. And if you don't see that option, there should be some kind of like Python options. Cool. So let's get data to import into our arrays. So we don't just have data sitting around in this GitHub cloud instance. We have to download it from somewhere. Before we do that, let's get it. Ooh, and this might be the first. Yeah, I see we do not have EarthPy installed, so we're going to have to install that too, which is cool. So Matthew, you have a question?
Not a question. I realized what I had done. When I was adding a new file, I didn't do it as a i.pynb. So when I do that, it looks
Okay,
As
cool.
Yours does.
Cool. So in the first line, I'm going to import OS and then NumPy as NP. And then here we're going to see that we don't actually have all the libraries we need, which I didn't realize until just now. So I'm going to show you what that error looks like, because this is an error you'll probably run into throughout your development journeys. And so we're going to install EarthPy. I'm going to find the docs for EarthPy. I think we can just do pip, but I want to make sure. Yeah, so based on the docs, we should install pip. Or we should install EarthPy, just for the sake of downloading the data. We don't have to do it this way, but just to follow the script a little easier, it's kind of worth it. So you see that I have pip install EarthPy. It's like, what the heck? How do I do that? Oh, so it actually worked even without putting the exclamation point. I thought that it would not work. So it's running, it's installing the things we need. Successfully installed a bunch of stuff. Now we should be able to import EarthPy as ET. So you can see how the error line went away. So now let's go here and rerun that. Now you can see we have EarthPy. So this isn't like the beautiful reproducible script that you'd share with your colleagues. This is us kind of learning on the fly, but you can see that even if you forgot to install something and put it into requirements, you can still install things after the fact. We could have also modified these requirements and added EarthPy. Didn't want to deal with that. Throughout the semester, we'll kind of explore different ways to do this. For day one, we don't really have to go all in, but towards the end of the semester, we'll have much more standardized processes for how to handle this. So we have all the dependencies or all the packages ready. So now let's download the data. So we're going to reference this file that's uploaded on a site called ndownloader.figshare.com. Monthly precip URL equals, for the case of URLs, I would strongly suggest copy pasting just because that's where errors happen. But that's the exception and not the rule. And so then let's invoke the EarthPy data get data method to download the data called, or the data from this source. And so we're going to do URL equals monthly precip source, precip URL. And so when we run this code cell, it's going to tell our computer to download the data from that URL. And then when it's done, it's going to tell us where it saved it. And you can see now we have in Earth Analytics, there should be a new folder. If not, we'll find it. Oh, it's doing me dirty. Okay. Let's see what happens when we do some ls. Earth Analytics data. Interesting. No such file or directory. Okay, EarthPy down. Oh. Let's see what it does now. Interesting. Oh, that's why. Okay. So it exists here somewhere. That's fine. It doesn't have to display in our file explorer. That's not a big deal. We just know it's at this path. So in our code, we just have to make sure to use that path. Okay. So now let's download the month names. So these are stored in a different data set. And so if we wanted to, let's see what this looks like. We can use some skills from last semester. It's cat. Oh, that's why. So you can see that this file just has some numeric data. There's no labels or anything. So now let's download the month names that we'll use to kind of label this data. Again, I'm going to copy paste the URL because it's very easy to mess these up. And then ut.get data, ut.data.get data URL equals month names URL. You can see it's downloading again to this file that's kind of hard for us to find. So it's a different file ending. Instead of it being average monthly precip, it is now months. And so if we want, we can inspect the contents of this file as well using cat. Just month names. So let's now, what else do we have to get? Download a CSV file. Okay. So this contains the monthly precipitation for Boulder for 2002 and 2013. Again, precip 2013 URL equals et data get data URL equals typing. Downloading this as well. And now we have 3 data files. So let's check out what this one looks like as well before we proceed. So not really any labels, just numeric data. Okay. Let's import this data into Numpy arrays. So to make our lives a little easier, we're going to set some working directories and use the OS package along with EarthPy. So let's set our working directory to the Earth Analytics subdirectory. We'll do OS shadir OS path join etio home Earth Analytics. So this line of code, we're using the os.shadir method to set the working directory, and then we're using the os path join method to join home and Earth Analytics in a way that's operating system agnostic. So the OS path join would work on Windows, Mac, or Linux, whereas if you're hard coding certain things, sometimes it's a mess. So this is just a safer way to handle that. There's newer ways to do this, or different ways besides OS shadir. Like pathlib is another library that lets you do this, but this is a tried and true method. So now we have changed our working directory. So let's import data from the txt file. We're going to use OS again and then jump right into Numpy. So let's define the file path. So fname equals OS path join data earth by downloads average monthly precip.txt. And then let's import that into a NumPy array. Using the load txt method, which is super nice. And then let's print out that data that we loaded into our NumPy array. Voila. And so you can see if we scroll back up to the average monthly precip cat line that we did, starts with 70, ends with 84. The same data set here, just in NumPy array format. And then if we do a type check on this, we'll see it's a NumPy array. And the ND array is just n dimensional. So it could be 1 through many dimensions. Now let's import some data from a CSV file. So we'll do fname equals OS path join data by downloads monthly precip 2002 2013.csv. And we'll use the NumPy load txt to read the CSV file. And we just will specify a delimiter of, did I spell that right? No, I didn't. Sure. Of commas. And then let's also print that out. So I'm being a little lazy. Print that. And then we can also do a type of this. And so you can see it's a NumPy array. And we have it in our variable now. We read it from a CSV file, which is kind of cool. And then finally, let's import text string data from text files into NumPy arrays. So remember, we downloaded the months as well. So let's try that. So fname equals OS path join data earth pi downloads months.txt months. Now we're going to use NumPy gen from text because we're using kind of text data instead of just numeric data. So this kind of helps us manage that. And now we're going to set the D type, the data type to string. Let's print months. And then let's get a type check on months. And the array. Cool. So this showed us 3 different ways to import data into NumPy. 2 are very similar, but kind of how you might handle numeric data in a text file, a CSV file, or string data accordingly. So this is the second lesson. Let's save our changes, commit our changes and push them to our repo, and then sync everything to make sure it worked. So I'm going back to this source control pane You can see we have one pending change for this new file that we created. I'm going to do commit and sync because I think that'll just do everything in one, so I don't have to click all those buttons. There are no stage changes to commit. Would you like to stage all your changes and commit them directly? Yes. I probably could have clicked always, but I just didn't. So now let's say finish lesson 2. And then we have no new changes to commit. So let's toggle back to the Explorer view. And you can see we can close this file now. Let's go return here and see if we refresh the page. You now have 2 Python notebooks. And this is the newest one we just did with the code that we put in. So yeah, all these red, like this is good to show that we tried and it wasn't installed. We learned and we updated in real time. So don't feel bad about turning in something that might have like errors like this. Like that's part of the process, and I want to see that you tried things. But yeah, we are officially, I don't even know how far the way out we're through. Let's check. So we did 2. We got 6 more. So let's get to it. Are there any questions in the meantime? If you're feeling confident, feel free to work ahead. Feel free to drop off, but I'm going to be here until the last person signs off. Just working through, getting my sea legs again too. I haven't been coding in Python too much, or coding in general too much lately, so it's fun to get back at it.
Quick question, Alex.
Yeah, what's up?
Yeah, I just want to follow up on the, like, after we commit changes. So I remember doing this all the time, and last time we were in class with you, but I'm rusty.
No worries. Yeah. So
yeah,
should
I'm
be-
just
Go ahead.
like, is it supposed to be in my repository? Like, I'm in my github.com, my name.
Yeah, I would love to. Oh, sorry. I just saw text. It should be in your repository that you created. Like when you're making these commits, are you clicking sync also?
Maybe not. I don't think I did that.
If you do sync, then it should populate. Because I think that might be the issue. Sometimes it's
Where
like
is
if you go back here to the source control view, there should be like a sync thing. I don't have it because I don't have any changes to commit. But there should just be like a sync option. Even if you like, is your commit thing green?
Oh, wait. What does it say? I think it said commit operation was canceled due to empty commit message.
Okay, yeah, you have to like type in at least something. Like, so try committing again. At the very top, there should be a place for you to input something. I've just been saying finish lab 1 or whatever, lesson 1. And so, or finish lesson 2. And so if you just type that in, and there should be a check mark at the top.
Okay.
Right?
Finish. Sync changes. I think I got it now.
Okay, cool.
Okay.
Yeah, if you check your repo, it should be updated with the files now.
I have a general question.
Yeah, what's up?
So how do you stop or how do you like disable the GitHub, like deleting a repo that you haven't used for a while?
Oh, that's probably some kind of user setting you have on.
Okay.
Yeah, that's probably going to be like at the top right where you're like, it's your little avatar bubble. If you click on it, there should be an option that says like your settings or something. Here, like you see like mine is this silly face. There should be an option for settings. I'm guessing it's in here. I haven't really heard about that problem, but it could just be some new thing that they've put on for people.
Yeah, just because like last semester's stuff, some of it got deleted and I wasn't sure how that happened.
The repos got deleted? That's super weird.
I think it sent us an email that was saying like, these will be deleted if you don't do anything with it. I don't know if you got that, Talissa.
I honestly might have. I don't check my emails enough though. So that could have been a thing.
Okay. If you wouldn't mind finding that email and like forwarding it to me and I can have a look, I think that'll help. But I'll do some digging too to see if there's some sort of policy that they delete after a while. I also have paid GitHub, so I don't know if that might be why it doesn't do that for me. But I'll look around. Yeah.
Yes, sorry,
Okay,
I just
thank you.
found it and I'll send it to you, but it says some of your code spaces are approaching the end of their retention period and will be deleted soon if you don't. So I think you just have to click continue using, but I don't know if we knew what.
Is the code space? I mean, I think it's fine if the code space deletes, but is the repo deleting?
It just said code spaces for me, so I'm not sure if Talissa it's your code space or your.
Okay. Because it's fine if the code space deletes, because that's just like we're just borrowing their computers temporarily.
Yeah,
So
I double checked and it's the code space. So that has nothing to do with the repo.
okay, good. Cool. We're good.
Yeah.
Sick. I was worried for a second. I was like, oh no, what's happening? But yeah, the code spaces, you
No,
can spin up a new one whenever using your existing repo as well. So it's fine. Oof. See you, Matthew. Yeah. Cool. Actually, before I jump into the next one, I'm going to have a quick snack. So I have little energy bars here. I'm going to stop sharing for like a minute and then turn off my mic so you don't have to hear me crunching. But if you need to take a break, go to the bathroom or something, now's a great time. I just want to eat one of these. It's a caffeine. These are actually really good. There's a grocery outlet by my house, and it's like vegan, gluten-free energy bars with caffeine. And so these hit when I need a little pick me up. So just give me a minute or two and we'll get back into it. And we're back. I guess I'll kill a little time for a second too in case anyone stepped away from the computer. But for anyone listening to the recording or any of you here, right now is like peak gorgeous time in the Joshua Tree area. The weather is spectacular. It's like sunny but not too hot. The flowers are starting to bloom. It's gorgeous. If you have time, would recommend to come up to the high desert during your spring break. Go to the national park, look at some trees, some cactus, some rocks. It's very peaceful and serene. Yeah, I just went to the national park last weekend because my in-laws were visiting and it was super cool.
My cousin just had her wedding there.
That's epic. Cool. I'm technically married already, but my wife and I kind of want to do a celebration in a year or so once we have some money to burn. But it would be cool to do it out here. We will. It's yeah, it's just we gotta get a car first. But yeah, courthouse weddings for the win. Affordable. Okay, cool. I'm gonna jump back in. Let me
Hey,
reach.
Alex,
Yeah,
I
what's
have a
up?
question. So, I was kind of following along with you and you had us save it in our notebooks really quick. And now I don't know how to save it without the notebooks. So all my changes are just going to the notebooks in my like repository. Is that okay to keep working off that? Like it's in the notebook, like I'm saving it in the notebook, like drop down. Is that okay?
I'm not sure what you mean in the notebook drop down.
So like right where you're, if you
Here,
like go down, no,
file
like
here.
no, right, like in like exit out of that.
Oh, for sure.
And then just like you had us go in the notebooks up here, in the demo. Yeah, right there.
Oh, like up here. Yeah, that's fine. I
Yeah,
mean,
up there. And so you had us start going in that. So
that's
it
fine.
kind of
Yeah,
started saving.
sorry.
Is that okay to?
Yeah, it's fine. Yeah, I'll
Okay.
take a look. Yeah,
Okay.
I'll make sure that it's not. Yeah, I was
Okay.
like, what?
Sorry. And then I was trying,
The
I'm trying to
notebook
save it
in the
outside the
notebook?
notebooks and it's not
What?
letting me. So sorry.
Okay, no, for sure. That's funny. I'm just like,
Okay.
it's Saturday morning. I'm like, well, caffeine.
Okay. Sounds good. Thanks.
Yeah, I'm definitely not going to be one of those instructors that like gets mad or frustrated about something. I mean, I might just be a little frazzled in the moment because I don't know what's going on. But like, yeah, feel free to just let me know if like I'm not gonna take points off for that.
Okay. Sounds good.
Yeah,
Thanks.
yeah. Also, yeah, Fernando, I feel for you, dude. Wallet is hurting. Cool. So let's start lesson 3. Run calculations.ipynb. So let's actually try a new way this time. I'm going to try touch. Nice. So it works too. And then we'll select the kernel, Python 3.10.13. And then let's open up this lesson. So it's more the same of importing Python packages. We're going to download the data again in case we don't already have it. I think we already have it, but we'll do it anyway, just because it could get wiped. And then we'll proceed with some calculations. So I'm going to move this over to the left so that I can conveniently watch and type. And if some of this feels like we're doing the same thing over and over again, it's because we are, but that's kind of intentional because there is some value in repetition and getting practice doing these, what might seem a bit mundane operations, but having that kind of second nature muscle memory will really serve you. And you won't even have to think about it'll just be in the background. You're thinking already about the problem and you're able to import the libraries you need. You're becoming Neo in the Matrix or Bruce Almighty in that one scene where he's typing like crazy. It's real. So we have those 3 packages imported. Let's see if we have the data already installed or already downloaded. Because I think it might still be there already. We don't, I mean, feel free to re-download things, but oh crap. Earth Pi downloads. Okay, cool. So we have those 3 files already. I'm not going to re-download them. I'm not going to do the ET data get data again because I don't need to. If you don't already have these because you maybe you just didn't save, that's fine. Just redo the ET data get data step. So I'm gonna now set our working directory to Earth Analytics because I know that did get wiped. pi. Cool. So we got our new working directory. No such file found. Probably spelled something wrong. Data. Interesting. Oh yeah, I'm looking at two lines at the same time. That's why. Okay. Sometimes it happens. You're like looking at two lines and you mix them both and you're like, what's going on? So OS errors are part of the development game. It just is what it is. OS patch join ETIO home Earth analytics. Cool. There we go. So now let's import our monthly precipitation data. Spelling. Okay. And then what's loaded into the Numpy array. And let's print it out. Cool. Looks good. And then let's import the monthly precipitation for 2002 and 2013 into an Numpy array. In general, it's bad practice to reuse a variable name if it's not in a function. So like we have fname twice, that's not like the best, but it's fine for the sake of this kind of like learning example. But in practice, you'd probably want to have like a function that just automates everything where you can just reuse it to point at a name and not have to overwrite fname in your code. So data EarthPy downloads, precip. What's a CSV? Okay, 2002 to 2013. Load txt. Fname. Delimiter equals comma. And let's print it out. Cool, that looks good. So now let's learn about some of the built-in NumPy functions that we can use to inspect our data. So let's do the ndim attribute of our array and learn about how many dimensions it has. So we'll start out with the average monthly precip and dim. It's a one-dimensional array. If we do the same thing for precip, we'll see that it's a two-dimensional array. We can also very quickly get information about kind of the dimensions or the shape. And so let's do average dot shape. And then let's do the same thing for precip. Cool. And so these are other ways to check that this is a one-dimensional, this is two-dimensional. And so a time where you might want to use ndim or shape is in like a data validation program to make sure that the data you're getting from your sensor fits the expected format. It's of certain dimension, certain shape, kind of like a double checking that everything is right to make sure that your measurements are correct and not suffering from some kind of sensor malfunction. So let's run some calculations on our data. So let's print the average monthly precipitation again. We see it's the array. And now let's use the assignment operator to convert the values from inches to millimeters. So let's do, because these are collected in inches, let's do the conversion factor of 25.4 to go from inches to millimeters. It would be 2.54 to go to centimeters, but it's 25.4 to millimeters. So we're basically taking everything inside of this array, multiplying it by 2.5 or 25.4, and then setting the array to that new value. So this is kind of like a shortcut. A way that you could also write this is average monthly precip equals average monthly precip times 25.4. These are kind of like equivalent ways of doing this. And so you might see this kind of notation where it's times equals plus equals minus equals, etc. And that's kind of what it means. It's just like a shorthand of not having to write average monthly precip twice. And so let's do this conversion. And then let's print out to see what the new values are in millimeters. And so you can see it converted successfully, which is cool. So let's do some more calculations. This was a one-dimensional array. Now let's try the same thing on a two-dimensional array. So let's print again the precip one, just so we have an understanding of what it kind of looks like, the baseline. Next, let's do that same conversion from inches to millimeters. So we'll do precip times equals 25.4, and then let's print out that data. And you can see that we're able to do similar multiplication, mathematics, arithmetic, what have you, on a multi-dimensional array, which is pretty cool. So you have a massive data set you need to convert between units. You can easily do that in like a single line. Okay. Let's briefly revisit Python lists versus Numpy arrays. And this will kind of help us highlight a key difference between the two. So when working with variables and lists, we created separate variables for each monthly average participation value to convert them. So we had to do like January times equals, February times equals, and then we had another list inside. So you have to do multiple nested lists. Whereas with a NumPy array, it's much more streamlined. If we were trying to do something similar with a Python list, it would actually just error out. And so we have this precip list variable. Let's try a similar times equals operation and see what happens. And you can see you can't multiply a sequence of non-integers by a float. And so one of the limitations of a list and also the flexibility is that you can kind of store different things inside of it. And you can't guarantee certain mathematical interoperability. And so that's when, if you're doing kind of numeric work, NumPy is oftentimes way more flexible and useful because you're able to just do these sorts of one-liners to convert an entire data set instead of having to like iterate row by row because of limitations of lists. So let's now go back to Numpy and learn about calculating some summary statistics on one-dimensional arrays. Something like a mean or a median. These are things that you've likely come across in your other coursework in GIS and I guess math and science more broadly throughout your college careers and even through your work. So we can quickly see how we can easily calculate these values in Python. So let's get the mean average precipitation from the monthly average precipitation. So we'll do the NP mean function. Average monthly precip. And then let's print mean average monthly precipitation. And then mean. So across those months, the average precipitation was 42.82. Let's do a similar kind of operation for median, which is another measurement of central tendency of a data set. So median average precip equals NP dot median. Very similar syntax. Print median average monthly precipitation. That's definitely not spelled right. Precipitation. Median average precip. Nice. And so you can see how the median and the mean are different. They're close, but they're not exactly the same. And so it's useful to kind of capture both of these values so that you can see if maybe there's some skew in the data set, or if you need to maybe double check your measurements, or just understand that maybe there's an anomaly happening here, or just some interesting environmental phenomenon. Besides median and mean, Numpy has a bunch of other built-in useful summary statistics functions. And we'll be able to reuse these throughout our semester in Numpy, but also in Pandas, GeoPandas, etc., because they're kind of nicely interoperable and connected in ways that we'll come to love. At least I hope. So let's now do minimum average monthly precipitation using, you guessed it, np.min average precip. And let's also print out the maximum. So the minimum average is 17.77 and the max is 77.47. Cool. So this was all towards one-dimensional arrays. Let's do this with a two-dimensional array now. So we're going to do this across rows to start. We're going to use that precip data set from 2002 and 2013. And so it should have 12 columns, one for each month. So 24 entries total. Let's use the np max function again, but this time we're going to specify an axis on which to calculate the data. And so by specifying axis equals 0, we're going to get the maximum value from each column across all rows for the years. So let's print out that precip data just to get a reminder of what it looks like. So 2 rows, multiple columns, 12 columns to be exact. Let's now get the maximum using npmax. np.max. Let's specify the axis as 0. Cool. And so here you can see we're getting 12 entries. So this is the average across the years for each month. We can also save this into a variable. Let's call it precip 2002, 2013, monthly max. And we'll set it to NP max, precip 2002, 2013, axis equals 0. And then let's check the type on it, just to make sure everything is looking good. So it's N, the array, and we know that it has these values. Great. Now let's try to calculate statistics across columns. So previously we did it for the rows. So the yearly or across both years. Now let's do it across, or for each month across the years. Now let's do it for each year across the months. So let's do print np max precip. And let's do axis equals 1. You can see the shape is different because it's just across the years. So this is for 2002. The maximum average precip was 81, whereas in 2013, it was 461. And we can quickly verify that here, looking at these data sets, 461, and then 81 is the largest one in the first year. So it's kind of trivial when you have such a small data set, but imagine you have thousands or millions of records. This is really nice, and it's able to save you a lot of time. And you can build more sophisticated reports using these programs. So now let's save this and commit the changes to our repository. Finish lesson 3. Now let's close this notebook. I'm going to return back to the repo and I like to double check. And you can see now we have a new notebook. Cool. So we're making progress, almost halfway there. Next, let's do slice or select .ipynb. I'm going to create a new notebook. I'm going to select the Python kernel. And now I'm going to open this here so that we can see the steps before we jump in. So this whole kind of lesson is about slicing or selecting data from an array. So it's kind of like looking for specific values in there that are of interest and how to do that. So I've previously teased that, like with lists, you can do the integer-based indexing. You can do similar things with NumPy arrays. So let's start out with indexing on a one-dimensional array, and then we'll move on to a two-dimensional array. So let's skip the first 2 lines where it says average monthly precip or precip 2002 2013. They're kind of just showing you the shape of the arrays. But we'll go down to where it says import Python packages and get data. To start, let's import OS, import NumPy as MP, and import EarthPy as ET. Next, let's check that the data is actually here. pretty sure. You're wrong. Somewhere. Okay, so now, oh yeah, it's at Earth, Analytics, Data, Earth, by cool. So we still have the data that we want. So I'm not going to re-download it. I will change the working directory again. Cool. Now let's import the average monthly precipitation data again. Good practice, even though we've done it a few times already. Let's do fname equals os path join data earth pi downloads average monthly precip dot txt average monthly precip equals np load txt fname. Cool, looks good. Let's do the same thing for the 2002 and 2003 data. Okay. Name and delimiter. It's comma. Let's print it out just to make sure everything is peachy. Looks great. Okay, but now let's get with slicing. So before we start slicing, let's get the shape of our data set using the shape attribute that we did previously. Okay, so we know it's a one-dimensional array with 12 elements. Let's get the last element of the array. So in Python, the counting starts with 0 so the last element of the array is going to be 11 in this case. If we tried to put 12, we will get an error. However, a shortcut you can do to get the last element is -1 as well. So oftentimes you don't want to just select a single element from an array, but a range of elements, maybe that satisfy some condition. So let's start out by just selecting a subset of an array. So we'll do print average monthly precip, and let's get the index 2 through index 5. Oops. See what it prints out. So you can see you got 3 values returned, starting with the third entry, which is index 2 because it starts with 0, through the 5th. Okay, so that's kind of all there is to it with the one-dimensional arrays. Now let's get to slicing two-dimensional arrays. So let's get the shape of this two-dimensional array. We can see it's 2 by 12, 2 rows by 12 columns. So now let's try to index, not just using one integer, but two, because there's 2 dimensions. So let's do precept 2002, 2013, 1, comma 2. So you can see that's from the second row and the third entry, if I'm reading this right. Second row, third entry, 1.72, 1.72. Because everything starts at 0, so your numbers are going to be off, which is a little tricky at first, but you get used to it. And so if you want to select the last element of the array, you can either use 11 or -1. So let's show that. So you can do 1, 11, or 1, -1. Actually, -1, 2. And so you can kind of go crazy with selecting subsets of data. So now let's slice a range of values. So you can also use the range for the row index or column index to slice multiple elements. So not just returning one, but multiple entries. So this is when it kind of looks a little trippy, and it might take some time to kind of orient yourself on how this works. There's a few practical examples, but you're able to really slice and filter across all dimensions. Let's do precept 2002, 2013, and then let's return 0 to 2, or 0 to 1, and then 0 through 2. And so it selects the elements in the first row, first 2 columns. So now we can flip these index values and select elements in the first 2 rows, first columns. Let's try that. And so it might seem a little arbitrary now, like why this matters, but depending on the analysis or how your data is subset, there might be ways where you can use this indexing to really narrow in on specific data that is more important. Cool. And then you can get pretty crazy. You can also omit the first index value if it starts at 0 and just do colon. So something like this, precept. And so you can get pretty sophisticated with how you're subsetting the data. And you can also use shortcuts to create new one-dimensional arrays from a slice. So we can do that here. Let's take this precept 2002 to 2013, the first row, all columns. Now let's set a new variable to this. So we're just doing precept 2002 equals this. Because if you recall, the first row is 2002 and the second row is 2013 data. Awesome. And then there's also an even shorter shortcut. If you know the specific row you want, you can just do precept 1, and that'll return the row. I encourage you, if you're feeling adventurous, to try out those NumPy array test at the bottom of this lesson, but this is kind of concludes the slicing selecting sub lesson for today. So as usual, I'm going to save and then commit and sync. Cool. So now return here. We have an additional notebook. All right, we got 4 more. It's getting exciting now. We're jumping into pandas. So this is kind of like doing spreadsheet type things with Python. Let's create another notebook. Select the Python kernel and get started. Actually, we'll see if there's any text that's of interest. So we've previously run into Python lists and NumPy arrays. Those are great, but sometimes you need kind of the best of both worlds where you're able to have different data types kind of connected and related, but still able to do mathematical computations, just like in a spreadsheet where there might be rows with text labels, numeric values, intermediate calculations, and just kind of whatever, categorical labels. And so in this chapter, we're going to learn about Pandas data frames, which is a really useful data structure in Python that makes it easy to work with tabular data like in a spreadsheet. And so let's now kind of see an example of a tabular data set that you might encounter when using Python. This is, or using Pandas data frames. This is a average monthly precipitation data set that we've been using all today. But you can see how here it's displayed in a more tabular format, not just an array or a single kind of column of numbers, but actually more human understandable, kind of akin to Google Sheets or Microsoft Excel. So you can have headers, which is super clutch in Pandas. So it just makes it easier to understand what's going on with the data set. Oftentimes you might have dozens of rows. If it's not labeled there where you're working, it's kind of tedious to have to remember and reference some external resource, some kind of lookup table. So here you can just work like a human would more naturally work with labels. So in this Pandas data frame, there's a column for months and a column for precipitation in inches. If we wanted to, we could generate precipitation millimeters using our conversion and have an additional data point. And we'll probably do that soon. And so in Pandas, you can work with data across an entire row, a column, or subsetting specific values. You can also kind of apply it to everything. It's pretty flexible in that respect. And let's jump right in. So this is kind of an arbitrary example of a Pandas data frame where the data has 2 columns, column 1 and column 2, and there's 2 rows. So value column 1, value column 2, and then value column 1, value column 2. This is very much a toy example, but shortly we're going to see how that looks with real life data. So let's start and pivot to the code. Again, we might have to import a library or 2, but that's okay. I'm going to start with importing pandas as PD. And then I'm going to try to import pyplot. I don't know if we have it installed. Looks like we do. Sweet. Okay, I wasn't sure if it was. So now let's create a pandas data frame using some data. Usually we wouldn't be hard coding in data, but like we started with arrays. Initially, we'll hard code in some values, and then we'll work on reading in data from a text file. So let's say average monthly precip equals PD data frame columns equals, and this is a list of the column names. Month, precip, inches. And then next, let's do the data that's going to go into our data frame. And that's a list of lists. So for this part, I will copy paste because I will mess it up. And I encourage you to do the same. Great. And now that we have this data set or this data frame, let's output it nicely. And you can see this is immediately a bit easier to understand what's going on compared to the Numpy arrays. I mean, there's value to the array, and to be honest, Pandas uses Numpy behind the scenes, but in terms of a more human-friendly experience, I think this is a little bit better, at least for me. You might be different, but for me, this is way nicer looking. So now that we have this data in a data frame, let's plot it. The nice thing about Pandas is if you have data loaded into this data frame concept, you can easily create plots, whether they're static or dynamic, but there's a lot of library kind of plugins that let you do really nice figures, both for scientific research, but also just for like more data science-y blog type things, examining the topics of Bob Ross paintings. You know what I mean? Like you can do interesting investigations and kind of display that graphically. So let's create a plot using PLT subplots. Let's take our average monthly precip data and plot it. We're going to set the x-axis to month. We're going to set the y-axis to precip inches. We're going to set the title to plot of pandas data frame using pandas.plot. And then we're going to set the axis to AX, which we defined in the first line here. So the Pandas engine knows where to put all this data. plt.show. And now you see this glorious figure of our data. There's other ways to plot this data that are slightly less verbose or just verbose in a different way. And so one such way is like this. plt.subplots. You can do ax.plot. Average monthly precip dot month. Average monthly precip dot precip inch. And then you can do ax.set title equals another way to plot stuff with pandas plt.show. And you can see we're generating these plots with code, which is kind of cool. And you could imagine how if you're working on a project where maybe there's a variety of study sites and you want to have a standardized presentation across all of them, you could have this plot in code, and then you're just pumping data into it, and it makes a beautiful figure that's kind of consistent across study regions. You can also make composite charts where you have multiple plots in one, and that's a cool way where I've seen in like academic articles, people have generated really nice maps with inset charts, and you can do that all programmatically. That's it for intro to pandas. Let's save this, commit it to our repo, and keep going. Commit and sync. Finish lesson 5. We want to close this. Let's double check the repo that it got updated. Perfect. Intro to Pandas. Now let's go back to our lab exercise instructions for the day. The final 3. Okay. Import CSV, that IPYNB. Let's touch. Import CSV. Let's select the kernel to be the Python 3.10.13. And then let's open this lesson. Actually, I'll keep it here for now. So like before, when we were manipulating CSV and TXT files in Numpy, we can do very similar things with Pandas. So let's do the same thing that we've been doing all throughout the day and just re-download the same data set or interact with this precipitation data. So to start, import OS, import matplotlib.pyplot as PLT, import pandas as PD, and import earthpy as ET. Awesome. So let's set the working directory os.shadir os path join et.io.home with earth analytics data. Nice. And now let's import our tabular data from a CSV file into a Pandas data frame. We'll see that this is pretty straightforward, if not easier than dealing with NumPy in my experience. Okay, so fname os path join earthpy downloads average precip months. You might not have this data, but we'll find out. Average monthly precip equals pd.read CSV fname. And then let's just output average monthly precip. So you can see there's no such file. So let's actually download this file. I thought we had it, but we don't. This is a new file we're using. So let's use that average precip URL. And then we'll do et data get data URL equals average. Cool. So it's downloaded there. Let's try this again. And you can see that it loaded in our data set in tabular format. We have the first index column, which is just kind of the positional index in the data set. We have a column called months, which is the label for the month of the year. We have a measurement of precipitation in inches, and then we also have the season of the year that it occurred. Now, that's kind of cool. We imported a CSV file into Python. Pat yourselves on the back. Next, let's try to plot a data frame. Let's plot this. So we'll do similar to what we did before. Big X equals plt.subplots. Then let's do average monthly precip dot plot. How about we do x equals months, y equals precip, title equals CSV via pandas, AX equals AX, and then ELT.show, I think. Nice. And so we want to do a bar plot this time. And so let's do plot, and then I'm not following exactly their script, but pandas offers kind equals bar. And this will let us do a bar chart. And there's different kind of preset options that pandas creates or allows, but you can really quickly, once you learn some of the basics, iterate on visualizations. So that's it for this mini lesson, importing CSVs with pandas. That was super quick. Let's save this one, commit the changes, and move on. Commit and sync. I was hoping to get out here by 12:30, so if we get out here by 12:30, I'll be happy. I won't be mad if we're out here after, but 12:30 is the goal. Finish lesson 6. Cool. Now let's check that everything looks good. Intro to or import CSV, great. And the nice thing about doing commit messages is you can see the order that you finish things, when you did it. If you're working on a team project, you can see when someone messed up or when they claimed they did something, but they actually didn't. And so when you're working in a team, this is super powerful kind of productivity tracking tools. Now let's go back to our course website, the final 2 lessons of the day. Let's create a notebook called run calculations.ipynb. Oops. Let's select. Oh, did I? Ooh, 2 of them have the same name. Okay, let me update this lab real fast. Didn't realize I set them both to that. Let's call this next one run calculations PD. So it's pandas. So let me take a second to load. But it should refresh once Gitbook realizes I updated it. And if not, that's cool too. There. Run calculations PD. So I'm going to close this one and I'm going to touch the new one. Okay. Run calculations PD. Select the kernel 310. So we had some exposure with methods previously without really calling out what methods are, but things like npmean or pd.dataframe, these are kind of methods that you're able to run on some kind of data in Python. And so these are examples of kind of the way things are structured. In pandas, you'll often see you're operating on a data frame. So you'll have like average monthly precip dot mean or average monthly precip dot max kind of thing instead of having a function. And so we're going to get exposure to that in this chapter. So let's do the old rigmarole and import the same things we've been using all day. If we really wanted to, we could have had just one massive Jupyter notebook. But that's kind of harder for me to grade, and you get less practice importing and just using your fingers to type. So that's kind of why I wanted us to do it this way, even if it seems a little less efficient. Plotlib.pyplot as PLT, pandas as PD, import earthpy as ET. So I believe we already have the average monthly precipitation data because we downloaded it in the last lesson. So I'm going to skip that line, but let's go to setting the working directory. And now let's import the data from the CSV file into a pandas data frame like we did before. Oh. See, we're using PSV or PD read CSV, F name. And note, we don't have to specify a delimiter. Pandas just knows. It knows to use commas by default, and it can kind of intelligently determine based on what method you're using, if what delimiter to use. No such file, earthpy downloads. Average precip monthly season. Okay, maybe I don't have the data. Let's check it. earthpy downloads. Okay. Average precip months seasons. Okay. I spelled it wrong. There we go. So we do have the data. Cool. Same seasonal monthly data set. Now let's get into it with some more pandas goodness. So this is a smaller data set, so it's not super useful, but imagine you have a multi-million record data set. You could return just the first or last 5 rows using the head or the tail method. So we have this average monthly precip. Let's do the head, and it returns the first 5 rows. You could also do head 1 and just return the first row. And similarly, tail works for the other end of the data set. Pandas offers some built-in methods to get like at a glance overview of your data set or your data frame. One of them is info. So you can see there's 12 entries. There's a column called months with 12 object type non-null entries. There's a precip column where they're all float 64, and then there's a seasons column. And so object is another variant of the string. And so when things are kind of a text data type, you'll often see them as object in pandas. And then we can also kind of get information about the specific columns. or the shape, similarly to Numpy. Another more kind of advanced or useful method on a data frame is describe, which actually gives you a nicely formatted output of some summary statistics on the kind of numeric data contained within your data frame. So it gives you the count, the mean, standard deviation, minimum, et cetera, some percentiles. And when you have a data set with multiple numeric columns, that can be very useful. So now let's calculate the median. Remember when we did with NumPy, we did np.median and then passing in the data set. Whereas here, we can just do average monthly precip dot median. Oops, remove that question mark. And you can see we got the median. Default value of numeric only in the future, default to false. Numeric only equals true. Just to turn off that annoying message. Cool. You can also run describe on just a column and not the whole data set. So here we did it on the whole data set. Unfortunately, there's only one column that's describable, but we could also do average monthly precip dot describe. Oops. And we get that same description. So say you're only interested in one column and you don't want to describe everything, you can just pass in a singular column. You can also do it with a single brackets, and I don't think that that really changes the output in this case. It just kind of outputs it as more of a Pandas series and not as a data frame. If you do the double brackets, it'll still format it nicely as a data frame. Whereas this other one, I believe, is just a series. Yeah, Pandas data frame. And then let's do type of this, Pandas series. So a data frame is made of multiple series. They're kind of like the columns of a data frame. So you have a data frame. You can sort it just like you would a spreadsheet. So let's take our average monthly precipitation. Let's just take a look at it. So now it's sorted by months, ascending. Let's sort it by precipitation. Sort values, and we'll do by equals precip ascending is false. So you can see the highest precipitation was in May in spring, and the lowest precipitation was in winter in January. And another thing you can do is run calculations on columns, kind of like how we did with the arrays. Let's take our average monthly precip, and we'll take the precip column, and now let's multiply it and set it to the millimeter conversion using the 25.4, and then let's output the data frame again. And here we'll see the precip has now been converted from inches into millimeters without changing any of the related labels. If we wanted to, we could also create a new column. And that would help us kind of maintain our original data or have both of the data points in inches and millimeters. Excuse me. So let's do that here. So I'm going to take average monthly precip. I'm going to create a new column called precip inches. And we're going to set that equal to the average monthly precip column divided by 25.4. Let's see, I'm missing an equal sign here. And now if we output our data frame, you'll see that we have 4 columns, one where we're measuring in millimeters and one where we're measuring in inches, which is pretty convenient. And then if we want, we can plot this data. Average monthly precip dot precip dot months height equals average monthly precip dot precip color equals purple. And then ax dot set title equals purple plot of precip in millimeters. plt dot show spelled something wrong. Oh yeah. plt dot subplots. And there we go. Another thing you might want to do is grouping data, which is oftentimes insightful into broader kind of trends in a data set. So let's do some group by operations. Let's get the precipitation by season. Precip by season equals average monthly precip dot group by. Let's group by seasons. And then we just want it to return. We just want to group by seasons on the precipitation column. And let's describe it. And then we'll put out precip by season. And so you can see we have fall, spring, summer, and winter. There's 3 entries for each season. And then we can get the mean, standard deviation, min, etc. across each of these seasons. So now let's try, and you can see now there's multiple indices. So it's like instead of just having the seasons index, there's the seasons and the precip. So let's see what I mean by that. So precip by season columns. It's thinking. It's freaking out. Interesting. Okay, let's see what's going on. Average monthly precip group by seasons. Precip dot describe. Happens if we just do this. Ooh, interesting. It's thinking. It's like it's frozen. I'm going to restart the kernel and see what happens. Could also be my win. And the storm started. So the internet cut out. Sorry about that. Let's keep going. I think I should have connection. Let me reshare my screen. Okay, here we go. So reload window. Cool. No, did I lose everything? That'd be sad. We're so close to. Okay, it's thinking. All right, let's see. I'm just gonna run everything again just to make sure it's connecting. It's thinking. Okay. Okay, I just want to run through to make sure things are working. It looks like they are. Okay. Now let's try to do that again. Where was I? Okay. There we go. Okay. So now let's drop a level of the indexing so that there's only one index. Namely, we're going to remove this precip index so it's only on season and count. So you'll see what I mean in a second. Precip by season, columns, precip by season, columns, drop level 0. Season, and you can see now it's not as weirdly formatted with this additional precip index at the top. Sometimes you might notice that when you do some group bys where it creates a new index, you just have to drop an index or kind of singlify it, to use a made-up word. So let's plot this. Another bar chart. By season. And then color equals purple. I feel like it's wrong. It's just like ugly. And then we got ax.set. Title equals something looks weird, but seasons. ELT.show. Great. And then we can also just run individual statistics if we were feeling so inclined, not just the group by or the describe. So let's do a few examples of that. Average, monthly recip, median, average monthly recip, group by, seasons. And then let's do precip dot median. Now let's display this. Nice. So we're getting the median precipitation across months. We can also run info on that. And get some information. You can see that there's an index created when we do this. So we could have redone this using a slightly different syntax. So let me just copy paste this here. We're now going to specify as index equals false. And now you can see the data is output in a slightly more friendly tabular format. Okay. I guess one more way to deal with indices. Say we have this average monthly precip stats data frame that we generate as such. Precip, oops, that is not spelled correctly. So you can see we have this extra index, and a way to get rid of that, we can reset the index in place like this. In place equals true. And then our data looks a little bit better. Okay, that was it for this kind of group by lesson. So let's save, commit our changes, and push through to the last lesson of the day. We might actually make that 12:30 ETA. Cool. All right, on to the final lab for today. Select data.ip1.b. So let's do touch. It already knows we want the Python 3.10 runtime. So let's get into it. So there's location-based and label-based indexing. We've kind of messed with some of the location-based indexing using the integer-based indices, but like the bracket 1 or bracket -1. But Pandas gives you some more fine-grained abilities to index and filter on a data set. So iloc is the location-based method, and then there's lock. There's also, I guess it's basically iloc and lock. And so we'll get some exposure to using both in this little mini lesson. So we're going to use the same familiar libraries that we've been using all day. Let me get to that. OS, import pandas as PD, earthpy as ET. Awesome. Next, let's set our working directory to the Earth Analytics subdirectory. OS here, OS, path, join, ETIO, home, Earth Analytics. And then let's import that CSV data into Pandas. Okay. Let's create a data frame called AVG monthly precip. And then let's display it. Awesome. Data looks good. Let's select some data using location indexing or iLock. So let's do average monthly precip dot iLock 0, 1, 0, 1. So that gives us the first entry in the data set. Let's try that with a different entry. 0, 2, 0, 1. And so here you can see I forgot to put iLock. So we got an error. Let's try again. This time we did not get an error. We just got the first two records in the data frame. So that's kind of cool. So the first two rows and the first column. You can also do the first row and the first two columns. That would be kind of the opposite. Average, come on, monthly precip. And then we want to do .ilock 0, 1, 0, 2. And you can see now we have the first row only, but the first two columns. And then we can select the first column with all rows like this. So that's just the first column with all rows. Next, let's pivot to using label indexing or lock. So let's set the index to months so that we can use month names to filter. So average monthly precip index is average monthly precip set index months. And now let's print out this new data frame. Cool. Now let's test that months no longer functions as a column, but is instead an index. So if we try to just filter into the months column, it won't really exist. So if we do average months precip index, and then we do months, so that's not defined. It's also because my internet is struggling and I spelled it wrong. So you can see here, there's no such months column. And if I try it with an additional bracket, similar issue. None of index months that are in columns, which is good because it's not a column. It's an index. So now let's filter down and index just to the month of August. So we can do that. Average monthly precip index dot lock Og. And so you can see we get the month of August, the precipitation level, and the season. So we're quickly able to subset our data based off of a kind of text label. So a quick note, Average monthly precip index or average monthly precip. This is a series. Ooh, my internet is slow. But if we want it formatted like a data frame, we just need to add additional square brackets. And this is kind of a shortcut to kind of transform it into the data frame mode. Cool. You can also do this with multiple columns. So you could do something like months, seasons. Oh, we got an error. Oh yeah, because I only have, I need more. There you go. And so you can kind of create a new data frame based off of the existing data frame. Oh, I have an extra. There we go. A 2-column data frame. And then if you want, you can actually filter based off of kind of a condition. So you can filter for all rows where season is summer. So you could do average monthly precip where average monthly precip seasons equals summer. And so you can see here, we are returned a subset of the data with just 3 records. If you wanted to, you could save this to a data frame, do additional computation, and that's pretty cool. You can also select you can select records based off of numeric values. So you could do average monthly precip, where average monthly precip is greater than or equal to 1. And so you can see here, it's only the months where there was more than 1 inch of rain. And that is really it. I mean, there's some additional kind of stretch goals if you feel so inclined, but another thing that you could do is plot this data. Oh, it doesn't know where to put it. Okay. But yeah, you can see it's you're able to reuse this information in many different ways and present it visually, but also in a tabular format. That being said, I think this is the last lesson of the day. Let's save these changes. Let's commit them and sync them before my internet totally craps out. Okay. Now let's double check that everything looks good in our repository. We have a new repo here, and you can see we finished all 8 of our lessons for the day. At this point, I'm going to close this code space. Don't actually know how to do that. It might be just, you just close it, I guess. Let's Google it together. Okay, so they're automatically deleted after they've been stopped and have remained active for a defined number of days. Default retention is 30 days. Okay. Well, then I'm not going to worry about it. It'll just delete in 30 days. Not really my problem. Cool. I guess, let me stop sharing. Are there any open questions? We walk through the lab. You kind of know what to expect. It's due in 2 weeks before 9 a.m. So 8:59 a.m. on the 13th. If there's any questions, don't hesitate to reach out to me. I've put my non-Long Beach email in the syllabus, so you should have access to me. Don't forget to put the code word in if you were here today to get those extra points for attendance. Otherwise, that's all I've got. Hope you have an amazing spring break and get some rest.
Thanks,
Hey,
Alex.
Professor. Sorry I was late. I didn't know there was class today. I thought I was going to start next week. So you're saying that there's like you have to put in points to get credit?
There was a code word
code?
that I shared in the chat earlier today for people that were here. And so that's yeah, I can if you scroll up to around 9:20 a.m. is when I shared it. I don't know if you have access to it.
I don't.
Okay, so I'll let me yeah, okay. How about so you're here. Okay. Yeah. Did the department not know or not let you guys know? Or how did that work?
I mean, it's partially my fault. I just assumed that since it was spring break that this class was going to start next Saturday.
Oh, for
yeah.
sure, for sure, for sure.
Yeah, so it's on me. So if not, it's okay. I just thought
Okay, cool. Yeah, then I just feel bad for the people that came earlier, but I wouldn't worry
Right.
too much about that extra credit point. There will be other opportunities throughout the semester.
all right, for sure.
Yeah.
Was it so? Is their class then next Saturday?
No, that's when it's spring break.
Okay, cool. All right. Well, then I'll see you in about 2 weeks then.
Cool. Yeah, have a good break.
All right, you too.
Yeah. See you.
Thanks,
Bye.
Alex. I appreciate it.
You're welcome. See you, Fernando.
Would you be available during this week for any troubleshooting, or we have
Yeah,
to?
yeah, just reach out. I mean, I'm not sure. I won't be like crazy responsive every day, but I'll definitely check my email throughout the week.
Okay.
So
Same way though, like last year on Discord is fine.
yeah, either one works. I'm just trying to be more like department approved, but like yeah, Discord is great. So either one.
Sounds good. Thank you so much.
Cool.
Appreciate it.
Yeah, thank you.
Take
See ya.
care.